So let's have our first example of a quadratic equation that uses completing the square method in solving for x. Now, in this example, we have x squared plus 8x minus 20 equals 0. It is a quadratic equation, but we are not going to factor. We are not using the quadratic formula. We are going to use the last method of solving for x in a quadratic equation, which is completing the square. And the steps are pretty long, but it's pretty simple once you get the hang of it. So let's start with the first step. So the first step in completing the square method is to always get rid of the constant in your quadratic equation. So here, our constant is negative 20, so we need to get rid of that because that's our first step. Move the constant. So add 20 on both sides, and you'll have x squared plus 8x plus a missing constant term, because you just moved it on the other side. So we will replace it with a box. So we have a box here and a box on the other side. So we have x squared plus 8x plus a box equals 20 plus a box. Now this 20 came from the constant that we moved a while ago. Now why do we have the boxes? So remember, if we have a box right here, we need to have another box on the other side, because the rule of algebra states that whatever you do on the other side, you have to do it on the other side as well. So you need to balance your equation. So that's what we're doing. So to balance it out, we need to figure out the number that we're going to place here in the box. And to do that, we need our perfect square trinomial. So just like what we did on the other step, the middle term will decide how to find the last term of our perfect square trinomial. And half of 8 is equal to 4. And then you square it, which gives you 16. So your number to complete the square will be 16. So that's why we have 16 on both sides of the equation. So this fills out your boxes. So we know that x squared plus 8x plus 16 is a perfect square trinomial. That's why we use this step. And to factor this out, we'll end up with x plus 4 times x plus 4 equal to 36. Now, to further simplify the two binomials, we can rewrite it into x plus 4 squared equal to 36. And as we know, whenever we have an exponent of 2 and we're solving for x, we need to get rid of this exponent. And to do that, we need to take the square root of this side and the square root of the other side. And make sure to add plus or minus in your square root. So every time you take the square root of both sides, you put the plus or minus sign on the other side of the equation. So x plus 4 squared with a square root, the square is cancelled out, the square root is cancelled out. Now you have x plus 4 by itself equal to plus or minus 6, because the square root of 36 is 6. And we're solving for x, so we need to have x by itself. Get rid of 4 by subtracting 4 on both sides. And now we have x equals negative 4 plus or minus 6. So we need two values of x's, so that's why we are splitting this into two. One is negative 4 plus 6, and the other one is negative 4 minus 6. So that's why quadratic equation always gives us two answers. The first answer is x equals 2, and the other one is x equals negative 10. And that's how we use the completing the square method. Okay. Now, we have x squared minus 4x minus 3 is equal to 0. And we're going to use completing the square method to solve for x for this equation. So we're going to use the method from scratch. So if we can remember it, we know that the first step is to always getting rid of the constant. So let's add 3 on both sides. And if we add 3 on both sides, we'll end up with x squared minus 4x plus a box equal to 3 plus the second box. And the number that we need to replace the box with will be from your middle term. Take half of 4 and then you square it. Half of 4 is 2 and 2 squared is equal to 4. So the number that will complete our trinomial will be 4. 4, 4. So now we have x squared minus 4x plus 4 equals 3 plus 4. This is a perfect square trinomial, so we can factor it out into x minus 2, x minus 2 equal to 7. And to further simplify this, we can combine them and we'll have x minus 2 squared equals 7. And once again, since we have an exponent of 2, we need to get rid of that by taking the square root of both sides. Square root, and I'm not going to forget my plus or minus here because I took the square root of both sides. So cancel your exponent and you'll have x minus 2 equals plus or minus the square root of 7. Now we're not finished with our solution yet because we still have negative 2 by x, so we need to get rid of that. So add 2 on both sides, cancel this, and now we have x equals 2 plus or minus the square root of 7. Now the square root of 7 is not a perfect square because to get the square root of 7 we need a calculator to do that. So we'll just use square root of 7 as our answer. And since we know that a real number cannot be added or subtracted with a radical, our answer will simply x equals 2 plus square root of 7 and x equals 2 minus square root of 7. So let me show you the two x's. 2 plus square root of 7 and the other one is 2 minus square root of 7. So these are the two values of x's that we are looking for.